Hello and welcome back to another IB Math speedrun with me, Vince. In this speedrun, we're going to be going through more on finding areas under a curve, and this time with partitioning. So let's jump right in. So sometimes if we need to find an area enclosed by, like, say, two curves and the x-axis and some line, it might not be possible to find it with a single limit. And so in this case, if you want to find this area under here, what we would have to do is we would have to get the intersection and then split this limit up. So to get this area over here, we get the limit of this first curve from 0 to whatever this A is. And then for this area here, we get the limit from A to, say, this B, whatever this B line is. And then we add those two up to get the total area under. So yeah, that's about it. So let's jump into some questions. I'll do the odd ones. So we need to find the area enclosed by the graphs of the functions y is equal to 4 over x squared, and y is equal to x minus 1/4 x squared, and y is equal to x squared plus 3x. So as you can see, we have three functions. And so this would probably work by having, I think, three intersections between the functions. So let's get these intersections. So first, 4 over x squared is equal to x minus 1/4 x squared. So 4 is equal to x cubed minus 1/4 x to the 4. Or actually, are we allowed to graph these? I think we're allowed to graph these and then just integrate them later. So let's just graph it on Desmos. So we get 4 over x squared. What is our other one? X minus 1/4 x squared. And x squared plus 3x. So I assume it's this region over here that they are referring to. So what the strategy is, okay, so they intersect at 0, at 1, 4, and at 2, 1. So the strategy is we need to get the limit between 0, 0 and 1, 4, 0 and 1 between this black curve and subtract the green curve from it. And then from 1, 4 to 2, 1, we need to get the limit of the red curve and then subtract the green curve from it. So we can do this using separate limits. So we have the limit of, what is our black curve? X squared plus 3x from 1 to 0 plus the limit of our red curve, which is 4 over x squared, from 1 to 2, minus the limit of the green curve from 0 to 2. The green curve being x minus 1/4 x squared. Of course, all dx, but I'm not going to write that. So we have 1, 0 of, this will be 1/3 x cubed plus 3/2 x squared minus 4x to the negative 1. Sorry, this should be separate. So this is between 1 and 2. And we also have minus the limit between 2 and 0 of x minus 1/4 x squared. Sorry, no, I mean 1/2 x squared minus 1/12 x cubed. So let's solve these. So we have 1/3 plus 3/2 minus 2, I believe. Plus 4. Yeah. Minus 2 minus 8 over 12. So minus 1/3, minus 2/3. Yeah. So what we have here is, if we just add all of this up, these will cancel out. So we get 1/3 plus 3/2 minus 2/3, which is 3/2 minus 1/3. So this should be equal to, hold on, wait, why are we subtracting? No, sorry, this is minus, so this should actually be plus. So we actually have 3/2 plus 1, which is equal to 5/2. So that is our answer. Okay, and on to the second one. The second question is, find the sum of the areas of the regions bounded by the graphs of f of x, which is equal to 1 plus x plus e to the x squared minus 2x, and g of x, which is equal to x to the 4 minus 7x squared plus 6x plus 2. And so some of the areas of the regions, let's just put these into the graph so we can see what they look like. So we have 1 plus x plus e to the x minus x squared minus 2x and the other one is x to the 4 minus 7x squared plus 6x plus 2. So I assume they're asking for this section of the black curve. Wait, no, what? Oh, some of the areas of the regions. Okay. So these curves intersect twice, I believe. So once is in this little area between 0, 2, and 0.925, and the second one is here, so between 0.925 and 2.201. I believe they don't intersect after that, but I might be wrong. Oh no, they probably do. And then between 3.229 and 57. So, anyways, let's integrate. So we have the integral of f of x minus g of x. So that is 1 plus x plus e to the x squared minus 2x minus x to the 4 plus 7x squared minus 6x minus 2. So let's just clean this up a bit. This is e to the x squared minus 2x minus x to the 4 plus 7x squared minus 5x minus 1 dx. So if we integrate this, we get, oh dear. Yep, so by putting it into the integral calculator, we get these three. And actually, I wonder if we can just range over all of them immediately. Okay, so I guess we can. Is this correct? No, it's not. It's not. So let's leave it as that, so we can add up 4.3 plus 14.6 plus 77.78. So we get something like 96.9 plus 7x squared. Oops. Plus 7x squared minus 6x minus 2. Okay, so wait, we need to change these a bit. So this is plus, minus, minus. Then here we have plus, minus, minus. 2. But we still get something that's much bigger than what the book gives, which is weird. But yeah, it's a weird question. Maybe the book forgot about this one between 2.2 and like all the way up there at 3. So I'm not sure. You know, tough question and pretty complex. So that was all for this speedrun. Hope you enjoyed, and I hope to see you in the next one.